In last lecture of material testing and evaluation, we have discussed about classification of rock, uses of rock in building construction and their properties. In this lecture, we are going to discuss about the tests carried out for finding out properties of rock or building stone. Myself, R.V. Zugdar, Assistant Professor in Civil Engineering Department, Sharda Institute of Technology, College of Engineering. For building construction or any kind of construction, the selection of stone plays very important role for quality work. The selection of stone can be done on following basis. For general building works, stone used for foundation, walls and superstructure, stones with high mechanical strength and the pleasant colors are widely used for the building works such as sandstone. Building exposed to high wind, stones with high crushing strength and the presence of silica in addition to hardness should be preferred as such buildings are constructed near the sea shore or location where more winds prevails. Building in industrial areas. The buildings are most subjected to polluted atmosphere which may contain harmful gases, acids and moisture. These elements leads to damage, hence stones that could sustain the effect of acidity and smoke on them are preferred for such kind of buildings. The stones are used for buildings exposed to heat and fire. Stones that have high fire resisting properties or stones which are free from calcium carbonate can resist fire. So this type of stone can be used in building which are frequently susceptible to fire. For building facing and architectural items, facing slabs and stones, part of stairs and landings, parapets and guardrail are made of slab splits from natural stone are worked on. For road metals and railway ballasts. Road metals and railway ballasts are subjected to high compression, abrasion, and impact loads. Thus, stones selected for such purposes should be able to resist thirst, must be strong and highly durable. Granite and quartzite are preferred for such purposes. Tests on building stones. The testing of building stone is necessary because good properties or good strength of stone may increase the quality of construction work. Building stones must be tested to assess their properties to use for various purposes. Some tests are simple which can be conducted in the field and some can be tested only in a laboratory. According to this, they are grouped as field test and laboratory tests. Field tests. The following field tests are carried out for building stones. Simple tests that can be performed on the stone because they are relatively simple. These include absorption test, Smith's test, toughness test, field hardness test, acid test, and crystallization tests. The first is absorption test. The test is carried out as follows. From the sample of stone, a cube weighing about 50 gram is prepared. Its actual weight is recorded as W1 grams. In second step, cube is then immersed in distilled water for a period of 24 hours. In next step, cube is taken out of the water and surface water is wiped off with a damp cloth. After that, it is weighed again. Let the weight of stone is W2 gram. In next step, cube is suspended freely in water and its weight is recorded. Let this be W gram. In next phase, water is boiled and cube is kept in boiling water for 5 hours. After that, cube is removed and surface water is wiped off with the damp cloth. Its weight is recorded in grams. From the above observation, values of following properties of stone are obtained. Percentage absorption by weight after 24 hours can be calculated by W2 minus W1 upon W1 into 100. Percentage absorption by volume after 24 hours is equal to W2 minus W1 upon W2 minus W3 into 100. Volume of displaced water can be calculated by W2 minus W3. Percentage porosity by volume can be calculated by W4 minus W1 upon W2 minus W3 into 100. The density of stone can be calculated by W1 upon W2 minus W3 kg per meter cube. Specific gravity can be calculated by formula W1 upon W2 minus W3, and saturation coefficient can be calculated by formula water absorption divided by total porosity, that is W2 minus W1 upon W4 minus W1. The next field test is Smith's test. This test is performed to find out the presence of soluble matter in the sample of stone. Few chips or pieces of stone are taken and they are placed in glass tube. The tube is then filled with clear water. After about an hour, the tube is vigorously stirred or shaken. Presence of earthy matter will convert the clear water into dirty water or brown water. If water remains clear, stone will be durable and free from the soluble matter. The next field test is toughness test. A rough test without any rigid specification or procedure. The stones are struck by hammer to gauge the toughness of stone. Force required to break the stone reflects the toughness of the stone. Field hardness test. Hardness is the resistance of the stone to indentation, rebound, or scratches. It is tested by penknife with the aid of Mohs scale of hardness. The following table shows the various Mohs scales and hardness tests. For talc, Mohs scale is 1, for gypsum it is 2, calcite 3, fluorite 4, apatite 5, ortho- orthoclase and feldspar 6, quartz 7, topaz 8, and sapphire or corundum it is 9, and diamond it is 10. The hardness test is shown in pictorial form in this picture. Acid test. Here a sample of stone weighing about 50 to 100 gram is taken. It is placed in a solution of hydrophobic acid having strength of 1% and is kept here for 7 days. Solution is agitated at intervals. A good building stone maintains its sharp edges and keeps its surface free from powder. At the end of this period, if the edges are broken and powder is found on the surface, it indicates the presence of calcium carbonate, and such a stone will have poor weathering quality. This test is usually carried out on sandstones. Crystallization test. 4 cubes of stone with dimension 40 mm are taken. Stones are dried for 3 days and weighed. Then stones are immersed in 14% solution of sodium sulfate, that is Na2SO4, for 2 hours. After these stones are dried at 100 degrees centigrade and weighed, difference in weight is noted. Process of drying, weighing, immersion and reweighing is repeated at least 5 times. Each time change in the weight is noted and it is expressed as percentage of original weight. Percentage of wear should not exceed 2% for good stone. The percentage of wear can be calculated by the formula W1 minus W2 upon W1 into 100. Now, after field test, the laboratory tests are conducted on construction stone, such as attrition test, crushing test, impact test, laboratory hardness test, microscopic test, and freezing and thawing test. Attrition test. This test is done to find the out the rate of wear or stone which are used in road construction. The result of the test indicates the resisting power of stone against the grinding action under traffic. The following procedure is adopted. Sample of stone is broken into pieces about 60 mm size. Such pieces weighing 5 kg are put both the cylinders of Devil's attrition test machine. Diameter and length of cylinder is respectively 20 cm and 34 cm. Cylinders are closed. Their axes make an angle of 30 degree with the horizontal. Cylinders are rotated about horizontal axis for 5 hours at the rate of 30 revolutions per minute. After this period, the contents are taken out of the cylinders and they are passed through a sieve of 1.5 mm mesh. Quality of stone is then entered on the sieve is weighed. Percentage wear worked out as follows by formula loss in weight upon initial weight into 100. Crushing test. Sample of stone is cut into cubes of size 40 by 40 by 40 mm. Sizes of cubes are finely dressed and finished. Maximum number of specimens to be tested in 3. Such specimen should be placed in water for about 72 hours prior to the test and therefore tested in saturated conditions. Load bearing surface is then covered with plaster of Paris of about 5 mm thick plywood. Load is applied axially on the cube in a crushing test machine. Rate of loading is 140 kg per square centimeter per minute. Crushing strength of stone per unit area is the maximum load at which the sample crushes to fails divided by area of bearing face of the specimen. The next laboratory test is impact test. This test is carried out to determine the toughness of stone. This test requires an impact testing machine. In this test, stones are filled in the test cylinder of diameter 25 mm and height of 25 mm. The cylinder is placed on machine and steel hammer weighing 20 Newton is allowed to fall on the specimen in cylinder. The height of first fall is 1 centimeter, height of second fall is 2 centimeter, and so on. The height at which specimen breaks is recorded. If specimen breaks at n centimeter, then n is toughness index of that particular stone. The next laboratory test is hardness test. For determining the hardness of stone, the test is carried out as follows. A cylinder of diameter 25 mm and height of 25 mm is taken out from the sample of stone. It is weighed. The sample is placed in Dory's testing machine and it is subjected to pressure of 1250 gram. The angular steel disc machine is then rotated at speed of 20 revolutions per minute. During the rotation of the disc, coarse sand of standard specification is sprinkled on the top of disc. After 1000 revolutions, specimen is taken out and weighed. The coefficient of hardness is found out from the following equation, that is, coefficient of hardness is equal to 20 minus loss of weight in grams upon 3. Next is microscopic test. The sample of test is subjected to microscopic examination. The sections of stones are taken and placed under microscope to study various properties such as average grain size, existence of pores, fissures, veins and shakes, mineral constituents, nature of cementing material, presence of any harmful substances and texture of stones, etc. In this topic, we have discussed about the various properties and tests to be conducted on building stones so as to check the quality or improve the quality of construction by using stones. Thank you.